Using glucose as an example, I can differentiate between empirical formula, molecular formula, and structural formula. The empirical formula of glucose defines glucose as a carbohydrate because it is CH2O, carbon with water, carbohydrate, with the ratio of carbon is 1 is to hydrogen, which is 2, is to oxygen, which is 1. So this is the empirical formula for glucose because the three elements exist in the simplest ratio, 1:2:1. Now, molecular formula of glucose is gotten from the empirical formula by multiplying the empirical formula with a number known as molecular multiple. By multiplying this with a whole number, n, and the number is 6. So this is the molecular formula for glucose. You can actually represent it by opening up the bracket. C1 times 6 is C6. H2 times 6 is H12. O1 times 6 is O6. This is also the molecular formula for glucose because it displays the actual number of atoms in the molecule. So actually there are 6 atoms of carbon, 12 atoms of hydrogen, 6 atoms of oxygen. The structural formula of glucose is still gotten from the molecular formula, but the difference is that we are going to display the bonds that connect these atoms. Now, one thing will enable you to draw the structure very well, and that is a kind of nomenclature for glucose. Glucose is called a polyhydroxyaldehyde. Now, glucose contains this, and many of these hydroxyl group. That is why glucose is called polyhydroxyaldehyde. Because of that, we are going to write this. Looking at this functional group, we have taken 1 carbon out of 6. So we are going to add 5 more carbon atoms, connecting them with covalent bonds. So if you count now, we have 6 carbon atoms. Now, we said glucose is a polyhydroxyaldehyde. This is the aldehyde carbon skeleton. So we are going to put many of these hydroxy groups, but we are going to be careful so that the number of oxygen will not be exceeded. Now that we have 1 oxygen already, we put OH here, OH here, OH here, OH here. Don't mind me, you can do it like this. You can alternate it, then put 2 to face the same side, or you can put all of them one side, no problem. We have registered 4, remaining 1, right? Now, that one will be here. If you count number of oxygen, you will still get 6. 1, 2, 3, 4, 5, 6. Now, what is remaining? Number of hydrogen. And we have 12 hydrogen atoms. We have already registered 1, 2, 3, 4, 5, 6. Remaining 6. So what you do is to fix those 6 to carbon atoms, ensuring that no carbon takes more than 4 bonds around it. So this carbon has taken 4 already. 1, 2, 3, 4. But this carbon has 3 bonds. Remaining 1. So we now fix 1 hydrogen there. This carbon has 3 bonds. We fix 1 here, fix 1 here, fix 1 here. This carbon has 2 bonds, so we fix 2 here. And this is the structural formula for glucose. Let's recount. Carbon is 6. 1, 2, 3, 4, 5, 6. Hydrogen is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oxygen is 6. 1, 2, 3, 4, 5, 6. I hope you got value. If you did, click on like, comment, share the video, follow and subscribe to my YouTube channel. Bye.